Welcome to the Deep Dive. We dig into research, articles, all sorts of sources, really, and pull out the key insights for you. Today, we're tackling artificial intelligence. But maybe not in the way you usually hear about it, not just big data or fancy algorithms. We're diving deep into something, well, much more human, more nuanced context. Our mission. To unpack this idea called Sophimatics. It's an approach that tries to genuinely connect human understanding with how we design AI. We've got some fascinating research to draw on folks like Gerardo and Giovanni Avani, Hollister and their team, McMenemy, and foundational stuff from Godin and Baddeley, Huback, Gomez, Nadell, Treisman, Gentaglia, and Bouquet, Zhang. Quite a list. Okay, let's unpack this.
Yeah, and what's really fascinating here, I think, is how Sophimatics basically says, look, human context is fundamental. It's not an add-on for AI. It's arguing that, well, just like for us humans, really effective AI, memory, and reasoning, they totally depend on understanding of the environment, the specific situation. It's about building AI that doesn't just crunch numbers, but actually sort of gets what's going on around it.
Yeah. Okay, that makes intuitive sense for us, obviously. But AI processes data, right? So what's the real bottleneck? I mean, what specific problem does this Sophimatics focus on context encoding and consistency actually solve that maybe other AI methods are missing?
Well, it's surprisingly close to how our own memory works. You know that classic experiment with the SKU bad divers by Godin and Baddeley? Divers learned words underwater, and they remembered way more of those words when tested underwater again compared to being tested on land.
Right, the context match.
Exactly. Context consistency, it boosts recall. Sophimatics tries to bring that idea into AI. So instead of the AI just storing isolated facts, these systems are designed to learn and store parameters about the environment, the situation, and their memory layers dynamically. It helps them adapt and perform better because they understand the context, which is something Hollister and the team highlighted back in 2019.
That SQA example really paints a picture, but, I think I read somewhere about human memory doing something weird with familiar places, something kind of counterintuitive. What's that about, and what does it mean for AI?
You're probably thinking of the work by Huback, Gomez, and Nadell. It's really interesting stuff. They actually found that people might be less likely to remember long-term memories when they're in super familiar places, like their own house.
Less likely. But that seems backwards.
Yeah, it does. The idea is maybe you need more specific, distinct context cues to pull up a memory when everything around you is familiar. It all just blends together. They termed it context independence in those situations.
Wow, okay, that really messes with how I thought memory worked.
Yeah.
So if our own brains sometimes struggle or need different cues in familiar spots, what does that tell us about building AI that's supposed to be smart and adaptable?
Well, it strongly suggests that really advanced AI needs to do more than just react to obvious context changes. It should also be able to dynamically figure out when context is subtly affecting a person's decisions or their reasoning, maybe even because a place is familiar. Building that capability in, like Hollister and colleagues suggested, could massively boost an AI's effectiveness and accuracy, especially for complicated tasks where understanding that human element is key. It points toward a more responsive AI.
Okay, so it's not just about memory, but also what the AI pays attention to, what it notices, right, in the moment. Which makes me think of, wasn't there that experiment by Treisman where people heard their own name in the ear they were told to ignore?
Exactly, that cocktail party effect, sort of.
Yeah.
Your name grabs your attention even when you're focused elsewhere, and that really highlights a crucial point. Attention massively influences what information the user actually perceives. And that, in turn, affects how an AI system should react.
Right.
So for AI to be genuinely useful and scalable, it can't be static. It needs this adaptive attentiveness, this ability to shift focus based on changing needs, situations, users. And in the Sophimatics approach, that's not just a concept. They achieve it using hybrid AI models specifically designed to weigh different contextual factors in real time. That's also in the Hollister work.
A hybrid model. Okay, that makes sense for handling dynamic stuff.
Yeah.
But the big question then is, how do you actually build that? How do you engineer a system that has this kind of, real-time awareness and adaptability? What does it look like inside?
Yeah, good question. Comes down to the architecture. Sophimatics uses a hybrid approach, mixing distributed neural models, kind of like artificial brain networks, with symbolic representation. Think of symbolic stuff as more like structured knowledge, rules, concepts. And studies, including some quite recent work from McMenemy, looking ahead to 2025, they keep showing these hybrid systems often outperform just neural or just symbolic ones, especially when things get complex and the environment changes. McMenemy's research on something called the Dynamic Cognitive Ontology Network, DCON, is a great example. It uses knowledge structures, ontologies that both machines and humans can understand. These explicitly map out contextual parameters. And this seems to give it a real edge in performance when dealing with messy, real-world environments.
We keep saying context, and it's obviously the core idea here, but listening to all this, it really doesn't sound like context is just one simple thing, is it?
Oh, absolutely not. It's way more complex. Gentili and Bouquet really dug into this. They talk about context having different facets, pragmatic aspects, cognitive ones, local details, compatibility. It's multifaceted. They basically concluded, and it's sort of the consensus now, that context isn't a single setting or variable. It's this complex thing that shapes how an agent, AI or human, reasons. And crucially, they point out that context isn't just something external you look at. It gets applied to the knowledge representation itself. It makes the knowledge usable, applicable. So Sophimatics really leans into this. It sees context as constantly shifting, changing, and deeply affecting how the AI perceives, thinks, and acts.
That deep view of context. Well, yeah, it feels like a really significant step for AI. It makes you wonder, how did older AI systems deal with this? Or maybe, how do they not deal with it?
Well, that's a key point. Early AI, think back to the 70s and 80s, often suffered from what they call contextual dependence. They worked, but only within very narrow, predefined situations. Take them out of that specific context, and they often failed badly.
Brittle, kind of.
Exactly. Brittle is a good word. Zhang wrote a critique pointing out how these early systems just couldn't recognize why context mattered, couldn't explain differences between contexts or adapt to them, that really limited where you could use them and how they could learn dynamically.
Right.
So Sophimatics tackles this head-on. It does it by deliberately building in principles about knowledge itself, epistemology, and how things are structured ontology. It's like giving the AI not just data, but the rules for understanding what that data means, how it connects, how it represents the real world. That's what lets it reason about changing situations in a way older systems just couldn't.
Okay, so going back to that idea of new information changing things, like hearing your name in the Treisman study reshaping your attention, even subconsciously, how does Sophimatics actually process information like that? It sounds like it needs to constantly update its understanding, maybe non-linearly.
That's exactly the challenge and how Sophimatics approaches it. It uses feedback loops, specifically something called recursive updating. Think of it like the system constantly checking back on itself as new information comes in, adjusting its internal state to accommodate changes, even subtle ones.
Okay.
This recursive process lets it identify and use the most relevant contextual information, no matter where that information is stored in its knowledge base. Hollister's team pointed this out too, and the core mechanism for this updating in Sophimatics, they call it contextual resonance.
Contextual resonance.
Yeah, it combines that recursive updating with actively interpreting the meaning of the contextual information. The goal is for the AI's internal state to resonate, to basically align perfectly with the dynamic conditions it's facing. It's constantly tuning itself to the situation.
Like tuning an instrument.
Kind of, yeah. And if we connect this to the bigger picture, this constant adaptation, this resonance, it gives the system much greater interpretive depth. It leads to higher quality, more nuanced performance compared to older AI models. And importantly, it helps keep the AI aligned with that core mission, achieving real contextual understanding for making reasonable, sound, maybe even more ethically mindful decisions. That connects back to both McMenemy's and Hollister's findings.
So wrapping this up then, what does this all mean for us, really? It sounds like Sophimatics isn't just about smarter algorithms. It's aiming for AI that doesn't just see data points, but actually understands us, understands the world around it, and adapts constantly to all those shifting contextual details.
Precisely. And thinking about that, it leaves us with a pretty big question, doesn't it? As AI gets better and better at understanding context, at being more like us in that sense, how might our own definition of intelligence itself start to change and evolve? Something to think about.